Hello, welcome to another video where we're working on what is it called? Odin's. So it's an interpreter for the Z machine, so it can play stuff like Zork, and it's written in Odin. So where we had gotten up to, I've refactored a little, but we're in the middle of the read instruction. Maybe I'll bring that over here and get to where we are. So we're in the middle of the read instruction, as we can see over here, where it's like kind of resizing. But the gist is, like we basically need to read input from the user, split it up into words, which words are kind of defined by some separators that are in the header. And then once you get all the words, you then need to encode the words as Z strings and then compare that with dictionary entries. So I guess in resize mode, hold on. It's because I like pulled it out. i3 does some like funky stuff sometimes. Um, so we'll just put that back like that. That's just to kind of fill a gap, which I think I want that more. Um, maybe here I just want something like that. Just for some visual interest, you can't even see what I'm doing now. It's in the secret room. Um, choo choo. Um, yeah, I'm basically pumping out SL in a little window I've got here. Except getting sidetracked. Anyhow, that is kind of what we were doing. And so I guess if we get to save this window, um, it runs. We can do some stuff. The comma and full stop word separators in this game file. So this should kind of split it into words. If it's a word separator but not a space, then it will become a word in its own right. So this is all the words that splits, which is printed from that print statement there. Is this like big enough? Maybe something like that, and this can just get dragged manually. Setups. I should like automate this setup, but it is what it is. So for encoding strings, really what I need to do is get a series of bytes, which would be the Z string. And then I can compare that with the dictionary entries because they're stored in numerical order of the bytes. So you can kind of just do a binary search based on the bytes that you have quite handily. So, what I've done, which maybe this will let me get there. No, it won't. Well, I can just go there manually rather than work out some vim. I think I'm in the wrong keyboard mode. Yeah, which mode am I in? I am in the unplug and replug mode. Can't remember what that color is, but yeah, that seems good. Not quite sure how I got into that mode either. Fancy keyboards for you. So the Z string code. This is kind of described by chapter 3 in general, but in specific 3.7, which gives some uh, limitations, I guess. So you can't have abbreviations. It doesn't mention anything about SCSIs. So if it's not in one of the alphabets, then so basically what I'm thinking is go along the word character by character, and see if that character. I'll probably instantiate a Z string structure as well, which can kind of help with the state machine for multi-character stuff. Though, like, because I'm just pumping them out, probably don't even need to do a state machine here. You could probably just be like, this character is here, so output this character, then this character. So, key thing is abbreviations, so not used, which actually makes it easier because, as I was saying, we can just go through the word as it is. It should be all lowercase already. Potentially, this should like assert on it, but it's kind of a well, potentially this should like convert the text into lowercase, but I think in this case, because I know it's getting called from here, I might go full screen and open up. Come on, you can do it, buddy. That's what I want. Um, so we can see here that when we read it, um, because like when you need to read it, you also need to do it. It checks whether it is in the right character set, pretty much, and also whether it is valid ASCII. Well, valid SCSI, which does it say it there? No, it says it here maybe. Uh, no, maybe it says it here. The specs are rather large and kind of split over weird amounts. Um, at some point, it says that it has to be valid SCSI. I'm sure of it. I can just search, but like in read, let me do a search. Nah, like it doesn't say it there. But does it say it here? The word separators can only do SCSI. So I guess like this. Well, like this is input, so what it should only be kind of valid for input like that. But like we're never gonna get. I guess we could like encode it manually, but that's kind of weird. Getting a delete or an escape, really. So I think this is kind of valid. We're basically saying only stuff that's input and output. Because we're both inputting it to the screen from the user, but we're also going to output it. It doesn't currently, but it kind of does. Like when you type it in, the terminal will echo it out. So what I'm thinking is pretty much for C in Word, I believe you can do that in Odin. And format del print, we'll just do that, something like that. And we can do this. And then it says hi, which is cool, which is our first word. So we also probably need to, well, we probably need to assert that data. Does assert have that? Have data pointer not weird keyboards, not equal to nil. Make sure that's that, and that way we know that that points to a valid place. Now, I wonder if you can do like pointer arithmetic, but I don't really want to do that. Can we turn a string into an iterator? I wonder if that's a thing. So I'm thinking of, instead of doing for C in Word, I can do traditional for I equals 0 and I is less than the length, because we don't want to overrun this data pointer, which is given to us. This analyze makes it either a 6 or a 9, so we don't really want to overrun that. And so yeah, I'm thinking of having I equals 0, I up to length I plus equal 2, because each z word is that. So where do I want to go? I want to go to core slash strings, core strings, and iterate. That's first non-space substring. Um, I don't really want to do like splits. I just want a normal iterator. And that's just in there. Cool. So I guess need to keep an index of something. I guess that kind of answers that question. So because it's probably easiest to iterate over the word. Like the for loop looks a lot nicer. Um, and I was thinking could either like do pointer arithmetic and like do plus equal to start with. But the problem with that is you can easily overrun the buffer. So you kind of need to know that you have like basically a length and an index. So the length is going to be how do you do it? It's like a hat data data pointer. Um, I actually forgot to check whether my camera is just completely white from the window behind. I hope it's not. I don't actually have a preview of the camera. I don't use OBS for whatever reasons. It's just everything big. Um, but yeah, I guess in here, yeah, we can do if index greater than equal to length. Um, do break something like that. And then for each character, we want to basically get uh, the Z string from it. So I guess we default to where is it? We default to a zero kind of. Well, we default to a zero in all versions except 1 and 2. And here it says shift characters. So 2 and 3 are shift characters, and here it says so shift block is used if there's more than 2. So we kind of need to know which alphabet we're in from that if we're doing version uh, 1 and 2. I kind of want to just say if well, we don't have a header. So let's get our header machine header and pass it our machine, and if header dot version less than equal to we'll just do unimplemented. And there's not actually that many games that are version 2. Like version 3 was kind of their first production release, I guess. There's like a couple of like very old stuff that you can find in version 2, but um, I think for now it just makes it a bit more complex than it needs to be. It needs shift blocks sometimes. Uh, B1 and 2 need shift blocks sometimes. Just actually, I'll just come and read the spec when I need to, if I even need to. Um, so this does that. So I think I'll just do maybe a switch of over C. And what do we want? So we can have, well, maybe it's more if alpha. Uh, how's this use the alphabets? Maybe I'll also do that because we have alphabets. Um, so if alphabet was it called that? I can't actually recall. Yeah, so this is a what was it? It was actually just go back to where I was and do that. It was a slice or an array maybe. This thing might be a bit better. Array, fixed arrays. Can we see if there's something in fact, see in, I'll see if that does it. I think I'm not allowed to do that, but we'll try. Yeah, so it doesn't like that. Um, this needs to be at the end. Um, that's all right. So I guess there is probably in packages. Slice contains. Well, actually, let's just search contains. ASCII set slice contains. I searched and it just didn't have. So I guess slice contains is what I want. Um, slice dot contains. So if this slice contains C, then we do do stuff. In fact, we can maybe do a bit more debugging. Uh, oh, alpha A, and just print C as well. Um, and maybe change that to a 0 because that's really what it is. And do something like this, that, and then that, and then that, and then that, and that, and finally that. Um, we'll probably need a final case. Scuzzy, I guess. Escape. So if we do this with our sample input, didn't like that because we lost the end one on there. We don't have slice. Well, we can add slice. Right, that's not a slice. What is that? Can we. What does byte stock contain? No. No. Um, do I need to um, do something like this? Um, yeah, that's probably what I want. And I think I might uh, do a test. And do something like that, just so we can see a bit more. Right, so here it didn't get the whole string, or I think I might put that there just as a safety. Right, so it is hitting there. That kind of makes sense. So Alpha 2 does have that, but the rest of these characters, I guess, are not in Alpha 2. Um, yeah, Alpha 2 is mainly numbers. Not everything up there. Email addresses would be 3 characters for the at sign. Um, right. So if we got that, we have our index. So I guess the is it like just truncated? Does the last character. Yeah, I think the last word should have that top bit set. So that can probably happen at the end. So we can do something like data pointer dash and take the uh, length minus two, minus 3 and have that equal to 0 x 8 uh, or um, that is the one, and data pointer hat length minus 3. Um, that sounds about right. Maybe a comment set top bit of last word. I think I might want to do another assert. Assert that length mod 2 equals 0. Basically, it is even. How do we want to do this? I think it's kind of annoying because we want a series of bytes which are the encoded Z string, but we're going to be getting Z characters which then need to be assembled into the soon. So I think after getting the length, probably want to make a z chars, and this can equal to make of uh, that, and we can just have u8, and we want this to be length uh, times 3, because there's 3 characters per every z character. um, 1, 2, 3, and each of them are in a word. Um, and because we're doing that, I will also do a defer delete z chars, because this won't leave the method that we're in. It's purely for that. And I guess that means that we want this index to be, wow, we want 2 indexes, data idx, we'll call it, data idx is less than that, and if the zchars idx is less than length times 3. Wow, maybe I'll do zchars length. Oh, I can probably just do like, surely that's reasonably cheap, or even cached. Um, Something like that, and maybe something like fzchars idx mod 3 equal to 0. um, then we are going to do this, implemented a symbol last 3 chars. And I think it does make have like a default value. Does this kind of show how to do makes? Make I kind of want to fill no. Is there a, we do have a slice dot fill. Slice dot fill. So it will be zchars. Was it the pointer to it? No, it was just kind of there. And I want to fill it with dictionary. The paired character must be 5. So I kind of want to fill that array with 5 to start with. Will you run? You won't quite run, because we also need the chars IDX to be that. Um, right, that's because we haven't unimplemented. I think with uh, I'll just do this little hack I do. Because I want to have the defer there and like kind of work through, but it's complaining about you can't actually finish this function because of that unimplemented. Um, right, so I think that we want to make sure that I think this check we want to do kind of at the end of this. I wonder if you can do like kind of blocks like this. Um, come on, go there and just deeper that whole thing. Mm, no, I think I'll do that down here, and I'll change it to if it is 3 because that at this point it should have processed 3 characters, and this should data IDX plus equal to 2 somewhere in it. Cool. So, I guess that's probably enough boilerplate. If it is an alpha 0, that's going to be easy. We just do data IDX, and this is no, we do the chars. The I wonder if make those even shorter. Now keep them long. Right, so this is going to be like 6 plus the index of it. 6 plus just plus that, not control plus. And could we get an index in a slice? Index, not that index. We can do binary search. No, I just it's kind of no, it's not really do that. Linear search. This is kind of what we want. Um, so there's no like, yeah, there's no just index. So I guess this linear search is what I want. So that's in slice, which kind of makes sense. So that is going to take, we can just do index, and it's going to have a found as well. And this is going to have slash dot linear search, search, and this is going to be zstring alphabet 0. And take a slice of it and do that, and probably do an assert found, because it's in the contains, we should know. And then we can just do 6 plus index. That's pretty much it. And if it is alpha 0, we want to do two things. The first one is yes, and this is going to also do the chars idx plus equal to 1. So this first zchars, that is going to be switching to A1, so that is going to be zchar 2. Three and later. So 4 and 5 are just shift characters, no shift locks. Yeah, weird. So because of that, that is going to be the shift of 4. Do that, and here we're going to have the next index be 6 plus index, and if it is, and then we also want to do something like that. And if it is the third alphabet, we want to do that, and we also want to do that, and we do want to do it over. And I guess because we're doing something like this, we probably want to do a check there. And because of that, I think we want to assemble the bytes here. Fixed me assemble words actually. Because it says that you want to have incomplete. You can have incomplete ones, so it gets a bit tricky. So the SCSI escape, I guess that's not going to be found in any alphabet, but uh, basically it's either going to be, well, it's never going to be new line, I guess. What does this Lexa do? Not that. That things. The Lexa lets a new line in, but it also checks for a new line, so that's kind of redundant. But yeah, it does the ASCII range, and then also there's extra characters, which I guess like the extra characters aren't really supported anyway. They're probably only used for printing, like input. Like it's defined for input, but um, I guess yeah, it's a bit trickier. Um, basically, if it's between 32 and 126, um, not that, um, that one, thanks. So, if the what do we have? We have C. Want to do the switch on C and do a case for um, 32 to 126. We'll do something, and if it is nothing, then we won't do anything. So I think that is kind of what we want to do. And if it is like that, and we needed, what have I done here? Do something like that, then that, do it again. So, what are they called? Extra characters. Extra characters. Something like that. So, in this is always going to have a what is it? SCSI escape. Character 6 from A2. So we need to do 2 bytes to kind of lead up. We need to get to A2. We need to check the next thing. Then we want to just do character 6, and then maybe check that. And here we probably just want to do and do something like that. And instead of equal to 5, I probably want this to be just equal to C. Though I'm probably getting a rune. So can I from a rune get just the like byte. Oh, it does have like nah, it's the last byte and that's a reader. Does have that. We're not dealing with a reader. Um, I'll see if it complains. I can probably just cast it. Do something like this. Um, okay, is that because do something like that? We have implemented that now. Um, yeah, so it is a rune. It's it did a thing. Um, it got to there. So I guess now we're just assembling those bytes, which we can probably do with zchars idx. Um, make that a z. We already have it in scope, and had that zchars idx less than ling of zchars. Gosh, that's what I wanted to do. Zchars idx plus equal to 3, I guess, and we can start this little loop here. So, and because of that, I probably want to make sure something like that, um, which should be fine because we kind of assert that. So yeah, it should be as simple as actually no, no. Scuzzy escape is done wrong. Yeah, the next character gives the top 5 bits and the one after the bottom 5. So I guess what does 126 in 126 so that is going to have 1, 2, 3, 4, 5. So it is going to have more than one byte. So I'll go back here and rethink this. Um, So we're going to have the code equal, it's going to be a U16. I mean, it might not, but so this is going to be the top 5 bytes. So to get the top 5 bytes, we would go code just down 5 and maybe do something like that. And I've gone into that weird mode again. If I like, I was off by 1 at some point. Off by 1 on the keyboard. I've got to put those keys in. No, not that one. Minus $, do those. And this code, we're also gonna make sure it's a U8. I guess we can do that here. And we're gonna end it with 0B 1, 2, 3, 4, 5. And here we're probably gonna have another case. This should be that. And this one just don't need to do that. And probably don't need to do anything there. And here we are actually adding 4. Cool. Still at the same point. Well, actually, no, we're not. Right, so assembling words. Assemble Z chars into Z words. So that means we don't need to do that check, kind of pointless. Which I guess kind of means I might just change this and do a zchars odx and just replace it with an index. Do it everywhere, ask me. Just to make it a bit clearer, and this no, because we need a loop over those. Well, we know what it is. Do the same there, thanks. Because the data index, data pointer hat, this is going to be index divided by 3 integer division. I assume it does integer division. Every other language does. Python doesn't, JavaScript doesn't. Yeah. So integer division of 3, because there's 3 things. Once you get 3, once you're looking at the third character, which is going to be 0, 1, 2, and 3 is like the next thing here. That is going to be the second index 1. z word, and 3 divided by 3 is 1, and everything less than that will be 0. Then after 3 more it will go up. So that's going to be the pointer that we're writing. So this, I guess, is going to be z char's index. Is that right, though? Um, I wonder if we can just have this as a U16, which means we'll have to go back to Alexa and search for U8, I guess, and make that U16, um, and do the same there. And that way, we don't need to do that. Um, uh, and just go to zstring thanks and go down the bottom. We've got an assert that we probably don't need to have a look at. So that probably makes more sense actually, because there's 3 z characters per word, and length is going to be the number of words. Yep, cool. Bit long this video, but it's a weird thing. So that means this is just going to be a word. So I guess we can have this word, and it's going to be the char's index, and this is going to go up 15, I guess. Um, No, it's only going to go up 10. But we're going to OR it with the char's index. And that's going to be 5. And I guess this, and finally at the end, it's just going to have z char's index. And this is going to be index plus 3. Yeah. Um, replace that with that. Replace that with, gosh, that one. Um, so I think I can do something like and search for that and do that, and then maybe search for that, do that again. We're in a mode. Get out of this mode, thanks. Um, oh, brain's starting to not work as well. Um, so I guess I also want to do something like ys dollar that, yeah, and here probably want to um and this word, maybe I'll call it a mask and make this mask and the mask is just going to be 1, 2, 3, 4, 5. Y, so do that one, do that one, find that thing, do that again. And this can be and mask and maybe find that thing, do it again. And something like that is going to be our word. And so here we can do word, except we're gonna need this to be +1. And then I guess that's only going to be +2. And that's going to be the word, I think. And then at the end, we make sure that well, really, we can just go length -1, -1, sorry, and set the last word. Yeah, I think it's a lot better working in terms of words. Um, um, Encodes each hours. Just because this is like a bit long, I wonder if this kind of zchars could be a different method. Z string encode the chars, and this is gonna take a do something like that, and U8. And do no, it's not going to return anything. It's just going to do that. I kind of want to make it just private. Do something like that, and then I can probably just replace this with the string encode zchars. Yeah, that first one, thanks. And give it the machine, and give it the word, and give it the zchars. But probably give it a pointer to the zchars. That's that one. Something like that. Maybe do something like that. Maybe even do golly. Need to see string encode zchar machine word and zchars. And before I forget, I'll paste that there. And here, find that and take the address. And this, I was thinking, can just get filled up with that. And here, find the data, and that's actually going to be zchars, just to make it easier. And I guess the breaks can actually just be return. case. Not that one though. And then if we exit the for loop, that means we can just return as well. Yeah, cool. That makes this like a bit clearer as to what it's doing. You can fit the whole thing in one thing. And I guess that means this can probably go up here. That's probably more belonged in that file. Cool. Let's see where it gets to now. It doesn't like that. That is because we need this to be that. It makes sense. Right. That is because we need to do that. Yeah, this, I guess, uh, should also do something like that, and then we can do something like that. And maybe do something like no, go there and there. Do that, then replace the chars with the chars IDX with a little hat, and do that everywhere and ask me. No, no, no. Oh, no, I'll come back to that. And yeah, I think this needs to do that. And I think I also want to do that and replace Lin. I need to like escape that. Z star back and replace that just with length. Thanks and ask me. It didn't find it, but did it find it without that? It did. Don't change that. Do change that. Right. Do that. Make. That right. So replace the chars IDX with the chars printer and do that everywhere. Made sense. Do something like that. Doesn't know about index. That's because we are just starting it here. Right, doesn't like this. You H this. U16 this. Will that complain? Yeah. So now I need to do U16 of that, maybe do that and do that. But also find that and at the end go back, do that, do some vimming. Cool. Index 19 is out of range. That is no good. Where does it do that? We overwrite index. Maybe I'll call that entry actually. This doesn't have an entry. Right, so now I guess we're not, yeah, implemented. So I guess we have now encoded the string. But we still need to find it in the dictionary. I don't have kind of an easy way to verify that the string is correct. Unless I just write it into a random chunk of memory. Like, sure, why not? For debugging. But we got U16s. Can we like recast it as UX? I don't know. I'm just gonna trust that it works. It will probably screw up another point. Because I'm pretty sure I don't have a way to. Yeah, because this takes the address and it reads words and whatnot. Oh, we do have like right word. So yeah, maybe I will for like I equals there as just to make sure that it kind of works. Call len data I plus equal to 1 and what are we doing in this for loop? We're doing machine writes word. We're going to write it to the machine. The address is going to be, I don't know, something like, we could probably just do 40. Well, it's going to be 40 plus I times 2, I guess. And it is going to be data I something like that. It'll probably complain, and then we can get the string read, and that takes a machine. We can give it our address and our lengths. We can just give 0, and this is going to return something. Got encoded string, pass it that thing. Um, and maybe something like word is going to be word, maybe even just to data, do something like that. Very hacky, but I just kind of want to get it. And maybe I can just do U32 of like all of that. Doesn't like this. We can just give it nil. Is that what we can do? So did this do the right thing? I don't think it did. Um, that is, well, no, encoded words. It's encoded words. I might just go here. And I might make it do something like this, and then do where's my percent there? Do not that with hex things. So it seems like it's not really filling up this properly. So I guess I want more debugging in the Z string. So maybe something like here, line, the chars, and pass it Z chars. And yeah, do that and run again. So this Z characters kind of don't look right. Like just not at all. So 13 would be well, actually 10, 11, 12, 13. Yeah, so it would be 13 and 14. 5 for that little thing. So these words don't seem right. And I kind of want to maybe go even back here and do 0 2x for that. But I kind of want to do 0 16 B. And yeah, it's not setting them right. I just realized in Z string the last byte we have here, we don't actually want it to be just that. We want it to be 80, which is going to be the last word, the top bit. Do sig no stop. So maybe even the characters I want to do. Maybe I could do %b and then percent uh, 0HB and just pass it in twice. Where are we going? And maybe this, I also want to kind of do a similar thing. Percent zero, just give it %b and %16b data, because it seems, yeah, I guess, Z characters look like they could be right, I guess. But yeah, this word that didn't get into here. Just it didn't. Um, and I just wonder why it did not. Um, I guess I could do something like um, yank around that. Um, go there, like that. Like that. There, around that. Do that. Thanks. And lots of debugging. Right, it didn't like. Let's not get there. So, a lot more debugging now. The first character, it's just not getting it. It's getting that last one, but for some reason it is just not getting. Um, do something like that. One more to keep them happy. Gifted without mask. here we can just shift that 10 and not do the mask. Then the last one will be the mask. And here, if we have a look, so shifted without a mask, it is fine. Yeah, I see what's happening. We want to kind of swap the order of these. Detool that. I detool that. Yeah. Paste it there, then detool that again. Go back, paste, detool that, go back, paste that, then search for that and go to the next one. Yeah, that didn't do it. I'll just do it manually. Want to do the mask before you shift, otherwise it will not actually do it. So I think that probably does the trick. That failed on something. So encoded words kind of looks all right at first glance. We have 1011. That is not the case up there. Maybe I do want can't get back there. Should get the mask. Should shift that up. So like 1, 2, 3, 4, 5. It starts here. Yeah, 1011. Then that kind of seems right. But it is now failing on output SCSI for extra characters. It hasn't set the top bit of that last one. Why has it not said that top bit of the last one? Last word is 0x percent 0 to x data pointer hat. Minus 1. yeah, last word doesn't have that. We want that for the last word. Yeah, that's looking better. So get rid of that printing, get rid of that printing. Um, Maybe get rid of that printing. And that looks about right. Except, oh yeah, so Word got that. It didn't get the, um, well, it truncates it. Um, it's looking good. I like the look of that. Um, get rid of that janky stuff, and I think that's probably a great place to just make sure it does that and like foo uh, um, yeah, crashes on Alexa. I'm happy with that. So I might make up a commit. Gosh, can we split that? Yeah, get rid of debugging. We're making that U16. Shifting the comment dot. We get slice. Can we split this? Can we see what this is? We're chucking a new function that does that. This is now doing a thing. Cool. Um, uh, Come on, get rid of these. And not control characters, encoding of z strings. So that's like great outcome. So I guess we're almost done with the read instruction. Once we get past the read instruction, it's back to the kind of boring up codes most likely. But you might also be able to play the game and kind of see different stuff happening. Um, so the next step that I'll be getting to will be not this usual stuff. Um, Basically looking them up in the dictionary, which is described in all of this pretty much. But um, and writing a parse table, which I do mention there. So yeah, basically need to search for the Z string entry, which the we will have 4 bytes, 4 words. We don't have 4 words. Code of text of Word, and it's always 4 bytes, which are 6. Yeah, so this is actually going to be 4, and this is going to be uh, it's going to be 4. No, it's going to be 2 words, and this is going to be 3 words. So that kind of makes sense. And if we look at what the commit was, it was 9 times 2 and 6 times 2. And um, yeah, always has 6 bytes, so that's gonna have that. So this isn't the Z characters. So I think because of that, I'll and I don't think that should make any difference. We can uh, do something like format.print line data, make sure it looks like it's got something in. Do something like that. Getting words. The second word looks significantly larger, so we'll have that top bit set. We could probably even do just to test uh, word. Actually, just give me the 04. Well, 016b. Do that and do that, and yeah, the top bit is set on all the last ones, and it's got 6 characters in. So it does truncate that, but yeah, from those 2 words we can do a binary search type thing, 2 words or 3 words. But yeah, there'll be another time. Make sure that's not dirty. Cool. I'll push that up, and that is all good to go. So it's up on my GitHub. It has some things going on. Gosh, I've been doing it a month now. Just trying out Odin. But yeah, no, this is going quite nice. I'm liking how we've nearly got ready. Anyway, slightly longer video, but if you've made it this far, thanks heaps. Let me know if you liked it. And yeah, until next time, I'll see you.